Class 7 Maths Chapter 1 Integers Animated Math Introduction. In Class 6, we have learnt about whole numbers and integers. We know that integers form a bigger collection of numbers which contains whole numbers and negative numbers. In this chapter, we will study about the properties and operations of integers. First of all, we will revise our previous knowledge of integers. Recollection of previous knowledge. Explanation. Let us recall step by step. Arranging integers in ascending or descending order, we know how to represent integers on a number line. Now look at number line below. Example 1. Can we arrange the marked integers in ascending and descending orders as well? Let us try. Solution. Ascending order. -16, -9, -4, 0, 3, 8, 14. Descending order. 14, 8, 3, 0, -4, -9, -16. Yes, it was a good attempt. In case of integers, the negative numbers are greater in reverse order. Example, -4 is greater than -5, greater than -6, greater than -7. Unlike the positive numbers, where 4 is less than 5, 5 is less than 6, and 6 is less than 7. Addition and subtraction of integers. Explanation. On a number line, when we add a positive integer, we move to the right. Add a negative integer, we move to the left. Subtract a positive integer, we move to the left. Subtract a negative integer, we move to the right. There are certain rules of addition and subtraction of integers. Rules for addition of integers. Greater number, negative. Smaller number, negative. Operation, addition. Result, negative. Example, -5 plus -2 is equal to -7. Greater number, positive. Smaller number, positive. Operation, addition. Result, positive. Example, 5 plus 2 is equal to 7. Greater number, positive. Smaller number, negative. Operation, addition. Result, positive. Example, 6 plus -3 is equal to 3. Greater number, negative. Smaller number, positive. Operation, addition. Result, negative. Example, -6 plus 3 is equal to -9. Rules for subtraction of integers. Greater number, negative. Smaller number, negative. Operation, subtraction. Result, negative. Example, -5 minus -3 is equal to -2. Greater number, positive. Smaller number, positive. Operation, subtraction. Result, positive. Example, 7 minus 4 is equal to 3. Greater number, positive. Smaller number, negative. Operation, subtraction. Result, positive. Example, 4 minus -3 is equal to 7. Greater number, negative. Smaller number, positive. Operation, subtraction. Result, negative. Example, -3 minus 2 is equal to -5. Additive inverse. For any number a, its additive inverse is -a. For any number minus a, its additive inverse is a. The sum of a number and its additive inverse is always 0. A plus -a is equal to 0. Integer 10, additive inverse -10. Integer -10, additive inverse 10. Integer 76, additive inverse -76. Integer -76, additive inverse 76. Properties of addition and subtraction of integers. Let us study the first property. 2.1. Closure under addition. Explanation. According to this property, if the sum of any two integers is an integer, then collection of integers is said to be closed under addition. In general, if a and b are any two integers, then a plus b is also an integer. Let us check this through examples. Examples. 5 plus 4 is equal to 9, an integer. Minus 4 plus 5 is equal to 1, an integer. Minus 4 plus minus 2 is equal to minus 6, an integer. Minus 7 plus 3 is equal to minus 4, an integer. Like this, we can check by taking numerous examples. Finally, we can say that integers are closed under addition. Now let us study the next property. 2.2. Closure under subtraction. Explanation. According to this property, if the difference of any two integers is an integer, then collection of integers is said to be closed under subtraction. In general, if a and b are any two integers, then a minus b is also an integer. Let us check this through examples. Examples. 4 minus 2 is equal to 2, an integer. 5 minus 6 is equal to minus 1, an integer. Minus 3 minus minus 6 is equal to 3, an integer. 5 minus minus 5 is equal to 10, an integer. Like this, we can check by taking numerous examples. Finally, we can say that integers are closed under subtraction. 2.3. Commutative property. Commutative property for addition. Explanation. According to this property, for any two whole numbers, a and b, a plus b is equal to b plus a. Let us check whether integers satisfy this property. Example. Minus 2 plus 1 is equal to 1 plus minus 2. 2 plus 0 is equal to 0 plus 2. 7 plus minus 6 is equal to minus 6 plus 7. Minus 7 plus minus 4 is equal to minus 4 plus minus 7. Like this, we can take numerous examples. Finally, it is clear that addition is commutative for integers. Commutative property for subtraction. Explanation. According to this property, for any two whole numbers a and b, a minus b is equal to b minus a is not true. Let us check whether integers satisfy this property. Examples. Minus 2 minus 1 is not equal to 1 minus minus 2. 4 minus 0 is not equal to 0 minus 4. 7 minus 2 is not equal to minus 2 minus 7. Minus 11 minus minus 4 is not equal to minus 4 minus minus 11. Like this, we can take numerous examples. Finally, it is clear that subtraction is not commutative for integers. 2.4. Associative property. Associative property for addition. Explanation. According to this property, for any three whole numbers a, b and c, a plus b plus c is equal to a plus b plus c. Let us check whether integers satisfy this property. Examples. 6 plus minus 2 plus 1 is equal to 6 plus minus 2 plus 1 equal 1 plus 2 plus 3 is equal to 1 plus 2 plus 3 equal 7 plus minus 1 plus 3 is equal to 7 plus minus 1 plus 3 equal minus 7 plus minus 2 plus 1 is equal to minus 7 plus minus 2 plus 1 equal. Since all are equal integers, satisfy the associative property for addition. So we can say that addition is associative for integers. Associative property for subtraction. Explanation. According to this property, for any three whole numbers a, b and c, a minus b minus c is equal to a minus b minus c is not true. Let us check whether integers satisfy this property. Examples. 3 minus minus 2 minus 1 is not equal to 3 minus minus 2 minus 1, not equal. 1 minus 5 minus 3 is not equal to 1 minus 5 minus 3, not equal. 7 minus minus 1 minus 3 is not equal to 7 minus minus 1 minus 3, not equal. Minus 4 minus minus 2 minus 9 is not equal to minus 4 minus minus 2 minus 9, not equal. Since all are not equal, integers don't satisfy the associative property for subtraction. So we can say that subtraction is not associative for integers. 2.5 Additive Identity. Explanation. The sum of 0 and any number is always the number itself. A plus 0 is equal to 0 plus A is equal to A. Example, 6 plus 0 is equal to 6. 3 plus 0 is equal to 3. Minus 13 plus 0 is equal to minus 13. 0 is called the additive identity for integers. Multiplication of integers. Let us learn how to multiply integers. 2.1 Multiplication of a positive and a negative integer. Explanation. When we multiply a positive and a negative integer, we first multiply them as whole numbers and then put the negative sign. In general, for any two positive integers, a and b, we can say a into minus b is equal to minus a into b is equal to minus a into b. Examples. 3 into minus 1 is equal to minus 3 into 1 is equal to minus 3. 4 into minus 7 is equal to minus 4 into 7 is equal to minus 28. Minus 5 into 11 is equal to minus 5 into 11 is equal to minus 55. Minus 7 into 6 is equal to minus 7 into 6 is equal to minus 42. 3.2 Multiplication of two negative integers. Explanation. When we multiply two negative integers, we first multiply them as whole numbers and then put the positive sign. In general, for any two positive integers a and b, we can say minus a into minus b is equal to a into b. Examples. Minus 2 into minus 5 is equal to 10. Minus 3 into minus 9 is equal to 27. Minus 5 into minus 6 is equal to 30. Minus 9 into minus 8 is equal to 72. 3.3 Product of three or more negative integers. Explanation. When we multiply odd number of negative integers, we multiply them as whole numbers and put the negative sign. When we multiply even numbers of negative integers, we multiply them as whole numbers and put the positive sign. Examples. Multiplication of odd number of negative integers. Minus 2 into minus 4 into minus 6 is equal to minus 2 into 4 into 6 is equal to minus 48. Minus 5 into minus 2 into minus 1 is equal to minus 5 into 2 into 1 is equal to minus 10. Minus 2 into minus 3 into minus 4 into minus 5 into minus 1 is equal to minus 2 into 3 into 4 into 5 into 1 is equal to minus 120. Minus 3 into minus 4 into minus 1 into minus 5 into minus 4 is equal to minus 3 into 4 into 1 into 5 into 4 is equal to minus 240. Multiplication of even numbers of negative integers. Minus 2 into minus 4 is equal to 8. Minus 6 into minus 4 is equal to 24. Minus 3 into minus 7 into minus 6 into minus 1 is equal to 126. Minus 6 into minus 3 into minus 1 into minus 2 is equal to 36. Properties of multiplication of integers. 4.1 Closure under multiplication. Explanation. The product of any two whole numbers is always a whole number. Let us check whether integers satisfy this property. Examples. 3 into minus 4 is equal to minus 12, an integer. 2 into minus 5 is equal to minus 10, an integer. Minus 5 into minus 7 is equal to 35, an integer. 7 into 4 is equal to 28, an integer. From these examples, we can say that integers are closed for multiplication. 4.2 Commutativity of multiplication. Explanation. According to this property, for any two whole numbers a and b, a into b is equal to b into a is true. Let us check whether integers satisfy this property. Examples: -6 into -1 is equal to -1 into -6 equal. -3 into -8 is equal to -8 into -3 equal. 2 into 4 is equal to 4 into 2 equal. 3 into -5 is equal to -5 into 3 equal. From these examples we can say that multiplication is commutative for integers. 4.3. Multiplication by 0. Explanation: any whole number multiplied by 0 is 0. Let us check whether integers satisfy this condition. Examples: -5 into 0 is equal to 0. 3 into 0 is equal to 0. -10 into 0 is equal to 0. It is true for all integers. In general, for any integer a into 0 is equal to 0 into a is equal to 0. 4 into 4 multiplicative identity. Explanation: 1 is the multiplicative identity for whole numbers. Let us see if it is the multiplicative identity for integers as well. In general, for any integer a into 1 is equal to 1 into a is equal to a. Examples: 2 into 1 is equal to 2. -5 into 1 is equal to -5. -7 into 1 is equal to -7. 4.5. Associativity for multiplication. Explanation: according to this property, for any three whole numbers a, b and c, a into b into c is equal to a into b into c is true. Let us check whether integers satisfy this property. Examples: 3 into -2 into 1 is equal to 3 into -2 into 1 equal. 1 into 5 into 3 is equal to 1 into 5 into 3 equal. 7 into -1 into 3 is equal to 7 into -1 into 3 equal. -4 into -2 into 9 is equal to -4 into -2 into 9 equal. Since all are equal integers satisfy the associative property for multiplication, so we can say that multiplication is associative for integers. 4.6. Distributive property. Explanation: in general, for any integers a, b and c, a into b plus c is equal to a into b plus a into c. Let us check whether integers satisfy this property or not. Examples: 2 into 1 plus 3 is equal to 2 into 1 plus 2 into 3 is equal to 8. -5 into -4 plus 3 is equal to -5 into -4 plus -5 into 3 is equal to 5. From these examples, we can say that distributivity of multiplication over addition is true. Similarly, distributivity of multiplication over subtraction is also true. 4.7. Making multiplication easier. Explanation: we can make multiplication easier by using the distributive property. Examples: Example 1. Solve the following. 16 into 12, 23 into -98, 7 into -6. Solution 1. 16 into 12 is equal to 16 into 10 plus 2 is equal to 16 into 10 plus 16 into 2 is equal to 160 plus 32 is equal to 192. Solution 2. 23 into -98 is equal to 23 into -100 plus 2 is equal to 23 into -100 plus 23 into 2 is equal to -2300 plus 46 is equal to -2254. Solution 3. 7 into -106 is equal to 7 into -100 plus 7 into -6 is equal to -700 minus 42 is equal to -742. Division of integers. Explanation: division is reverse operation of multiplication. When we divide a positive and a negative integer, we first divide them as whole numbers and then we put the negative sign to the quotient. In general, for any two positive integers a and b, minus a divided by minus b is equal to a divided by b, where b is not equal to 0. Examples: 72 divided by minus 8 is equal to minus 9. 50 divided by minus 10 is equal to minus 5. Minus 12 divided by minus 6 is equal to 2. Minus 45 divided by minus 9 is equal to 5. 6. Properties of division of integers. 6.1. Closure. Explanation: whole numbers are not closed under division. Let us check whether integers satisfy this property. Examples: minus 8 divided by minus 4 is equal to 2. Result is an integer. Minus 4 divided by minus 8 is equal to minus 4 divided by minus 8. Result is not an integer. From these examples, we can say that integers are not closed under division. 6.2. Commutativity. Explanation: in general, this property under division is written as a divided by b is equal to b divided by a. Let us see whether integers satisfy this property or not. Examples: minus 6 divided by minus 3 is equal to 2. Result is an integer. Minus 7 divided by minus 6 is equal to 7 divided by 6. Result is an integer. From these examples, we can say that division is not commutative for integers. 6.3. Division by 0. Explanation: like whole numbers, any integer divided by 0 is meaningless, and 0 divided by an integer other than 0 is equal to 0. That is, for any integer a divided by 0 is not defined by 0 divided by a is equal to 0, for a is not equal to 0. 6.4. Division by 1. Explanation: like whole numbers, any integer divided by 1 is the integer itself. In general, for any integer a divided by 1 is equal to a. 6.5. Associativity. Explanation: in general, this property under division for any three integers a, b, c is written as a divided by b divided by c is equal to a divided by b divided by c. Let us see whether integers satisfy this property or not. Examples: minus 16 divided by 4 divided by minus 2 is not equal to minus 16 divided by 4 divided by minus 2. Minus 1 divided by 4 divided by minus 2 is not equal to minus 1 divided by 4 divided by minus 2. 10 divided by 4 divided by minus 2 is not equal to 10 divided by 4 divided by minus 2. From these examples, we can say that division is not associative for integers.